So now we're going to evaluate the double integral of the curl of f in S. So we know the curl of f is equal to 1i, and we can use Stoke's theorem with polar coordinates to evaluate this. So first we need to find the polar coordinates of set sphere and the derivative of it. So we know that normally if we are in an x and y plane, that x can be written by r cos of t and y can be written by r sine of t for circular coordinates. But since we're in a yz plane, we know that y will be r cos of t and z will be r sine of t. And where the radius is 5, we end up with these two equations. And x will be 0. So next, we will have the equation r of t equal to 0i, 5 cos of t for j, and 5 sine of t for k. And we can take the partial derivatives with each coordinate to have 0i minus 5 sine of t for j, and plus 5 cos t for k. Now when we sub in the coordinates to our vector field f, we have 0i, 0j, and negative 5 sine of t, k, which leaves us with negative 5 sine t in the k. So now we can evaluate this using the theorem. Now we know that our theta is going to be going from 0 to 2 pi, our t, so we can sub that in immediately for our bounds of our integration. And we can put in the f of r of t being negative 5 sine of t and take the dot product with r prime of t. When we do that, we get negative 25 sine squared of t. And we can now evaluate this integral by simplifying it and then using a reduction formula for a sine with to a greater power, and use that formula here and find out that our final computation gives us negative 25 pi. So the double integral of the curl of f, that is the gradient crossed with f in S, is equal to negative 25 pi.